Hello everyone, or anyone. We're going to try this, even though I'm having some setup issues, we're just going to go for it. So today I wanted to do a quick live stream slash video record, if you will. Talking about a item I designed. I've been getting into playing a video game lately and doing that here on my desktop so that I can stream it on Twitch. Check those out, they're pretty funny. And for that, to have any decent control instead of the keyboard, I went with the Xbox controller. And what I wanted to do though is I need to have this sit in front of me, in front of my keyboard, so that I can, reasonably control it, reach over, hit the keys, get the mouse over here to manage the stream or what have you. And I really need this to sort of sit in front of me, kind of like, so it's got this little tab out front so that I can put a clamp on the countertop, and otherwise it just cradles the controller and keeps it in place so that I don't have to constantly put it down and pick it up again. So I got a 3D printer a couple of years back. It's been all sorts of fun printing various stuff. Check me out on Thingiverse. We got 20 odd designs, something like that, available. Various useful and not so useful things. So designing this stand, we went ahead and used Fusion360. So here is our stand in sort of the completed design. And here is it printed. It's kind of a little mini-me version of that one, huh? Which you would expect, right? So I had to put this little bit of Velcro here to kick the controller back. It was a little bit too far forward like this. I could have redesigned it and reprinted it, but it works well enough. And then it was printed in these two pieces so that they could print one flat on the print bed and not have to have any support except on those little curved parts. Kind of messed it there. Again, that's okay. It's more functional than appearance based. So we'll go ahead and sort of retrace our steps. What we're going to do is just rewind to our various components. And then just sort of move forward from here. I may have to move things around on my desktop to see what I'm doing. So, one of the first things we needed to do was figure out this shape. The shape around here and on the bottom that would be used to cradle the fingers, if you will. So how we figured out this shape. Can't seem to do it with the pinky. So this shape, this sort of profile here. And I did that in a couple of iterations. What I did first was I took this piece, you can barely see it here, let's maybe switch back to the other scene. The controller on the stand. A little easier to see here, it's almost visible. So I took this little piece of twist tie and used it to sort of capture this shape underneath. And then we put this on a piece of graph paper and brought it into Fusion. And let me just make sure we have everything visible. So there's our sketch. And that sketch was based off of this canvas. And here we go. So what I did was I took the bent up wire, put it on a piece of graph paper, tried to take a nice flat-on photo of it, although maybe not so exact, and that gave me the profile. So from that, I just copied the sketch a bit, and it's a little bit different than the shape, and that's because we went through a couple of iterations printing out a little thin section. We got this profile, right? And that's the profile of the cradle. And to begin with, all I did was extrude it a little touch, right? So now we have this. Now we have this little thin 1 millimeter thick piece of plastic. And what I was able to do with that was readily print it out into a test piece. And here is that test piece. If it has the same view. So this was the first version of it. And we line that up with the controller, if that shows it, and then there's this gap, right? There it goes. Bit of a gap, right? So we went in, shrunk it a bit, and came out with version 2. And version 2, what's that? Oh, I had a little echo in my ear. Version 2, almost, still just a little gap, right? So we adjusted it, came up with version 3. And sure enough, version 3 is a pretty close match. Not a lot of slack there. Fits nicely into the cradle area. Right? So, spend a little bit of time printing thin profiles like that. Make sure you get the shape before you go further. So we get that profile. We know it works and know it's going to fit. So now we're going to go ahead and start making the actual cradle itself. So we'll hide that body. And we'll take a projection of that body. Make a new component. We create a new sketch that is a projection of that other component's sketch, so that when we change the underlying component, if we needed to change this profile shape again, it would cascade throughout the rest of the changes we've made. One of the benefits to parametric design is you can go back in, change a little bit, and the rest of your changes, for the most part, cascade. There's times where you can make geometry that's invalid for the previous, or for the things you've done later, and you have to patch that up. But by and large, if it's all done correctly with proper projection links, and not too much reliance on tight radius fillets and the like, you can, you know, the original drawing takes almost the same amount of time as doing it manually. It's the edits that are so much faster with the tools. I started off doing drafting when it was a T-square and a board, and it was all paper based. And then not long after that got into AutoCAD, Autodesk's AutoCAD that was almost completely given away to students for a while there. So I've got a long history of these different tools. And by far I like the parametric designs of this and Onshape. Didn't really use the predecessor to Onshape, I forget the name, but mostly because it was too expensive. So we're going to take this sketch, extrude it out to a thickness of the finger. So in this case, we've just extruded this piece. It actually looks backwards in my, well, Yeah, there. Yeah, that piece. So now that that's extruded, we don't need the sketch anymore. And then we're going to do another extrusion of this profile here, but do it at an offset so that we get this gap between the pieces. So there we go. Now we got our other finger. So we've got our two little fingers. Now we're going to make this area between them. And we do that by drawing out just that rectangular part in between. So now we more or less have the cradle, except it's got a whole lot of sharp edges. So we'll round off sharp edges here and there. And one more for this inner edge. And now these had to be a tighter fillet, smaller fillet than these, otherwise I got invalid geometry. So that's pretty much the cradle. Now we're gonna tilt the cradle to 45 degrees, which, like I said before, I think I've been better at 40, but good enough for now. Then we're gonna start our new component. That's gonna start with a new sketch. There it is. Looking for exactly which sketch that was. There we go. So this sketch draws a circle on the back. Of the thing, and that's going to be our column. We draw a circle flat there, but we actually want to project it out and make it a vertical column so that this becomes an ellipse. So to do that, we create an offset plane, construction plane just below it, and then using that plane we can draw a sketch. And on all the sketches, not sketch 1 and 2, or sketch 3. Actually, the sketches are in different components. That's what's happening here. So now we have the cradle, and we've projected the circle that's on the back of the cradle to being an ellipse on this plane. And now we can extrude that ellipse in two directions. One down this way, and one up to the top. So we extend it up to this surface, and then down some distance to make it a total of about 3 inches tall. That's what I was aiming for. So now we've got a stand. We're going to make another sketch and project the back of this, the rest of the back, have it projected down, and then round off the edges a bit. So we have that. So we'll extrude that up, so because I had my height determined already, we extrude up to create a thickness. What I've generally found is about 3 millimeters thick is good for plates and clamping areas. Things that you're going to clamp onto other areas, you want that to be at least 3 millimeters thick if you're going to have any amount of less than solid printing. So now we have this one little plane right here. We need to draw that out. So there's a convenient set of tools in here. You can draw your diagrams and extrude like we've been doing so far, or you can just use these push-pull tools that push-pull on a given piece of geometry and extend it or shrink it. So we're going to use a push-pull to draw that pad out. Then we're going to start filleting. We need a nice fillet around the base there. We're going to round off those edges. Going to produce a chamfer. And the reason I'm using a chamfer instead of a fillet is that when it comes to the low level like this, the fillets tend to get kind of squirrely in the printer when you're doing a fillet in the Z direction. Fillets in the X and Y direction are nice and smooth because that's the print head moving around. Trying to do a fillet where the print head is just incrementally drawing a layer after layer and backing it up so that you end up with a curve like this. That can get dirty and squirrely. So generally I stick with chamfers in the vertical and only fillet in the horizontal and what is it, X and Y, and only chamfer in the Z. Now I kind of broke that rule, of course, with this piece because this is going to be printed with this piece on the print bed. That leaves a bunch of overhang here that has to be printed with supports, and as you can kind of see from the camera, you know, those layers don't necessarily print all that smoothly. See if I can get a focus. Yeah, there you go. Now you can really see the lines that didn't quite smoothly print. Again, it's functional, so I don't care about too much of the view. All right. So here we are with our stand. A couple of other things we needed to do. We needed to, I mean, we could have printed this just as is, and there would have been a whole lot of support material supporting the underside of the cradle. Been a big mess, a whole lot of extra plastic. So instead I want to cut it into two pieces, key them together so that they'll go back together correctly. But cut them into two pieces so that I can print them separately and then just glue them, or in this case I don't really think I'm going to glue it because once this velcros, oops, gotta keep it centered. Once I velcro it to the controller, well then I can just sort of pop it onto the stand like that. So I can pick it up and still use it even though the stand is going to be clamped down. You see that's just a little bit too upright. I would have preferred it just a little bit further back. But it works good for now. So, next steps. Let's get rid of some of these excess sketches that we don't need anymore. And this construction plane. Don't need to see that anymore. Now we're going to key it, right? So we got to draw some design. In this case, I decided to go with a little hexagon key. Hexagon shaped key. So it's a hexagon when looked at straight on, and it's kind of this slanted hexagon when cut at an angle. So first we got to draw it. So I drew it on the same plane, construction plane, as we did the extrusion. Now we're going to take that and extrude it up to this surface. And you can see they're kind of fighting. The red and green is fighting. And that's because they're interfering with each other. If we hide the stand at this point, the base, then you see there's actually no hole in the top. We're just creating two parts that are interfering with each other right now. So, but we do have this nice hexagon cross section as a key. So the next step is to subtract the two. That's pretty straightforward. We subtracted the two now. Now we've got a nice hole. We used the stand as a tool and the cradle as the target, and then said keep the tools afterwards, of course. And that made a hole in the cradle for us, but it's right now it's exactly the same size, and that's not going to give us enough wiggle room with the printer's dimensions. So the tolerance here is maybe 0.2 millimeters, about half a nozzle's width. I went ahead and did a 0.3, and the way I eased that offset was to create another construction plane up here. Again, let's look at that side here. Above everything. And project that hexagon up there as a sketch. So that's the projection of the hexagon. And then offset this projection by 0.3 millimeter to give it enough room. Then we're going to extrude this little hexagon outline back down to this construction plane. And in doing that, we'll have cut just a hair off of all of the surrounding, or all of the sections, rather, all of the surfaces of our hexagon key. And that'll give us enough clearance that we can slide it on and off and not have to be forcing it. So with that, we do that extrusion. And now you can see, let's get rid of construction and sketches. But now you can see there's a little bit of a gap between the two. Just enough to make it to where they can slide on and off easily. So if we scroll back, there we go. And so just the cradle without the base and the base without the cradle. That's pretty much it. So that was the design process, and process by which I went to getting this all prepped, and then exported these two as STL files and uploaded them to Thingiverse and printed a test piece. I'm pretty happy with the test piece. I love this gray PLA. It really shows up well on camera. It's not too flashy. It doesn't reflect, make things noticeably blurry or anything like that. So there you go. Quick little Fusion360 exercise, and now I have a unique stand. Yes, I know. There's others already on Thingiverse. There's dozens of Xbox controller stands on Thingiverse, but it wasn't the one I wanted. And since I have a 3D printer, I can print 3D plastic dinguses all I want. So, anyway, hope this helps anyone who's interested in Fusion and wants to design some sort of complicated thing like this. It's complicated enough, but Fusion makes it pretty simple. These commands of fillet and the fillet and chamfer commands pretty much make it easy to make a nice rounded, smooth handling item. If you didn't ease these edges with a tiny fillet, you'd end up with a bunch of, well, sharp edges, right? And that's just uncomfortable in something that you're handhold or that you're handling. And so you'll see almost every design of something that is handheld, there's these eased edges, and these could have been chamfered instead of filleted. And the chamfer would be a little bit cleaner. And of course, this shape here could have been squared off. It's in the back of the controller, and I don't really see it or touch it or anything. But I didn't want it to interfere with the button action either. So, you know, there's trade-offs in your design all the time. Alrighty. Well, I hope that was useful for folks. And I guess we will see you next time. Bye.